So the last function characteristic that we're going to look at is end behavior. And so we don't really have a super formal definition for this, but it's basically asking what is going on at the end of the graph. And so we use this crazy looking notation. And so we deal with infinities. And so we say it as x approaches negative infinity, f of x approaches something. So as x approaches negative infinity, if you think about your number line with 0 in the middle, negative infinity is to the left. So this first piece is asking, what is the left side doing? On this side, as x approaches positive infinity, f of x approaches, and then we'll fill in the blank. As x approaches positive infinity, if you'll think about a number line with 0 in the middle, positive infinity is on the right. So what is the right side doing? So if we look at our first example, which is a left side, so this over here is a left side. Is the arrow going up or down? It's going up. So mathematically, when we write it as x approaches negative infinity, so the left side, f of x approaches, it's going up, and that would be towards positive infinity. So this would be one piece of it. And then we're going to look at the right side, because that's the other end. Is the arrow going up or down? Well, it's going up. So mathematically, the right side, as x approaches positive infinity, f of x approaches positive infinity because it's going up. So if you were to just kind of think about this as simply as possible, and I said, what's the end behavior? You could say up, up, and then we'd be good to go. But we're going to write it mathematically. So if we look at another example over here, we've got another parabola. We're going to look at the left side first. So as x approaches negative infinity, this piece will always be there. F of x approaches, and we're going to fill in the blank. It's going down, so it approaches negative infinity. So then the right side, as x approaches positive infinity, what is f of x doing? What's your y value doing? Well, it's getting more and more negative, so it approaches negative infinity. So if I said, what's your end behavior? If you wanted to say it really, really simply, you would say down, down. So you've got negative infinity and negative infinity. If we just keep looking at some examples, this is a cubic function. So the left side is over here. Hopefully you know the difference between your left and right. We're going to ask ourselves, is it going up or down? Well, that arrow is pointed down. So when I write it out formally, as x approaches negative infinity, that always stays the same. F of x also approaches negative infinity. It's going down. Then the right side, it's going up. So as x approaches positive infinity, that just means what is the right side doing? F of x approaches positive infinity. So if I were to say really simply, this end behavior is down, up. It's pretty simple. It's pretty quick. All right, and then your end behavior on this one. So we've got two sides of the function, left side and right side. This left side function, as x approaches negative infinity, what is f of x doing? Are my y values increasing or decreasing? Well, that graph is getting a little bit taller, so we would say it's increasing, and so it would be approaching positive infinity. And then on the other side, the right side, as x approaches positive infinity, this arrow is going a little bit down at a time, and so my end behavior would be as it approaches negative infinity. So if I said it really simply, I would say up, down. So we'll do a couple of examples, and we're going to put all of the stuff that we know about functions together. So starting with domain and range, x and y intercept, increasing, decreasing, positive, negative, and end behavior. So my domain, let's see if we can put everything in there. Domain is left to right. On the left side, I have an arrow. And on the right side, I have an arrow, so that means I'm approaching infinities on both sides. So my domain is going to be from negative infinity to positive infinity. My range is bottom to top. And so the bottom of my function never ends, so we'll have negative infinity until we reach that vertex up at the top, or that maximum at 3. I have two x-intercepts. That'll help me later with positive, negative. So let's say one x-intercept is at a negative 3.7 and the other one is at about negative 0.2. My y-intercept is where it crosses the y-axis. So we'll have 0, -1. Remember, x and y intercepts are not intervals. They're the exact location. We're actually naming the coordinate point. How many over, how many up. And then increasing, decreasing, we'll trace it from left to right. So I start by increasing, so the first part of the domain, and then it switches over to decreasing. So I increase from the beginning of the domain until this x value of -2, and I decrease from -2 on. I am positive above the x-axis, and I am negative below. So we've got two pieces for negative. This is where our x-intercepts will be helpful. And so we're positive between those x-intercepts. So we're positive between -3.7 and -0.2. And we're negative the rest of the time. So we're negative from the beginning of the domain until -3.7. And then we pick up being negative again at the other x-intercept at -0.2. We use that union symbol to say we've got two pieces of negative lines, I guess, in your function. And then lastly, end behavior. Your left side going down, your right side is going down, so both of those we would fill in with negative infinities. We'll look at one more, putting it all together. You can always pause if you need to. All right, so let's look at the domain. So we see we've got arrows on both sides. So my domain going to be -infinity to +infinity. My range, I've still got arrows on both sides. So my range is actually going to be the same as the domain, -infinity to +infinity. My x-intercepts, -2 and 3. My y-intercept, I've got one of them at 3. My function, if I trace it from left to right, we start by decreasing or going downhill, then in the middle we increase, and then on the other side we decrease. So it's kind of a crazy roller coaster looking thing. And so increasing, we increase from -2 until my x value here is about 1.5. And then we decrease the rest of the domain. So we decrease from -infinity to -2. And the second piece of decreasing picks up at 1.5 until infinity. My function is actually mostly positive. Most of it is above the x-axis. It stops being positive at that second intercept. So it's positive from -infinity, the beginning of my domain, until 3. And it's negative from 3 until infinity. When you fill in positive, negative, and increasing, decreasing, if you'll go back and check, it should include all of your values. It should include the entire domain that you already identified. Go ahead and highlight that -2 so you can see it. All right, and then my end behavior, my left side is going up, so I'd have positive infinity, and my right side is going down, so I would have negative infinity. So there's more to practice, but that's putting it all together. This is primarily what we'll be doing. We'll just have them all together. You'll have a table to fill out, and then we can check and see what you know.